Hi, I made some pictures I think that will be useful to understand the difference between many worlds and the model that I'm proposing. And I think that if you could try to draw these pictures in the process of drawing them, you would learn a lot about how these things are working. So let me explain what's going on here. Of course, we can't draw a picture in full space-time with 3 space dimensions and 1 time dimension. So let's start as simple as possible with no space dimensions and 1 time dimension. That means our universe is simply a point in space, but which experiences time. All right? So we suppose that at this point events can occur, and each event has 2 outcomes. In this picture, the event outcomes are either pink or purple. Of course, this is a very simple picture. You would have different kinds of events, but I think just for simplicity, we're going to assume in this universe there's just one type of event, and it happens repeatedly, and it's either pink or purple in its outcome. All right. So, in this picture, green represents the different physical worlds. By the way, this dimension here, this is time going this way. So let me indicate that. This direction is time. And as I said, there's no space dimension. I would say that this here is a discrete dimension. You can see that there are several lines here. So this would be the world index. Okay, so this is a sheet. I can call this line 0, line 1, line 2, line 3, line 4, line 5, and of course there are going to be many, many more lines farther. So green represents different physical worlds, okay, and pink and purple represent 2 alternative outcomes of an event. So for instance, in world 0, you have an event occurring here, 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 and here. In world 1, you have an event occurring here, here, and so on. World 2, here and here. I kind of lost patience. I hope in your picture you can put more events. Now, each time there's an event, there's a branching of world lines. So you can see at this point, world line 0 splits into world line 0 and world line 1. Now, the way I've arranged it is just that I've made it so that the purple line jumps. It really is arbitrary. There's nothing special about world line 0. All of these world lines are equivalent. I just put world line 0 as continuous simply because that's easy to do. And so you can't say world line is continuous and world line 1 is not continuous. This is a splitting between 2 worlds. Okay, so it just shows a difference. Now you may see in other pictures about many worlds, they represent it differently. Let me show you. For instance, here's the Wikipedia article, and here they show an event happening and a splitting of 2 worlds. Okay, so this is the same thing that I'm representing, but it's hard to do this when you have multiple splits, and I want to emphasize that in my picture I only have no space dimensions and 1 time dimension. All right, because later on I'll do a picture with 1 space dimension and 1 time dimension. All right, so the green represents different physical worlds. Pink, purple represent 2 alternative outcomes of an event. Each one of these world lines has events at different times. I mean, here you might have other events here. As I said, I didn't draw them. If I had another pink event here, I would have to create another branching. So there would be another branch up here that goes to a world up above. Okay, so here also this purple would have more events. There would be more events here, and so on. All right. So you can see that the number of of I shouldn't say the number of branches, I should say the number of lines increases exponentially. Let me fix that. Okay, so here I have the number of world lines increases exponentially. Let me make this a little bigger. Maybe it's easier to read. Sorry about my bad writing. Okay, the number of world lines increases exponentially. Let's see what's going on here. All right. So all of these, again, this should be lines. Let me fix that. So all of these lines together constitute the physical world. All right, that seems kind of paradoxical, but explain a little bit more of that. So the topological structure of the physical world is very complicated. All right, let me zoom out again so we can just read it. The topological structure of the physical world is extremely complicated. Now, topological, it kind of means how these things fit together. When you have branches, that changes the topology. So you can talk about a wiggly line. A wiggly line is topologically the same as a straight line, but a branched line is topologically different from a straight line. So in some way, a wiggly line is simpler than a branched line. Okay. So the topological structure of the physical world is very complicated and is growing exponentially in complexity, because every time you split, you are adding another. You're adding another possibility. So you can see that basically, as time goes on, the number of branches increases exponentially, because children have children and so on, just like population increases exponentially. Now, why does this seem so unlike our experience? Well, according to the many worlds interpretation, we are on one of these. What we experience is just being on one of these. So my experience is here. However, there's a copy of me in some other world, on all these other world lines that are having different experiences. So we experience being on one of these branches, but alternate eyes have different experiences on the different branches. Now, this is kind of hard to swallow, but a lot of physicists do believe this. In particular, Sean Carroll has a lot of material that explains his viewpoint on this. All right, now, different events are correlated. This is in terms of statistics. I think you saw the concept of correlation between different events. So these events basically affect each other because the occurrence of each event depends on which line it's on. Okay, let me zoom out again so I can read it. Because the occurrence of each event depends on which line it's on, right? So the events on this line occur the way they do because of what happened previously. And the events on this line occur because of what happened previously. This event here does not occur the same time as the event down here, just because these are different lines, so they're different correlations. Okay, so that's why the different events are correlated. And the line it's on depends on previous event outcomes. Okay, there's nothing special about the green line at the bottom. All branches are equally part of the physics, all right, of the physical universe, although they may have different probability weights attached to them. One or the other of these different lines may have different probabilities. This one may be more probable than the one at the bottom. So that's why that's where the probability in quantum mechanics comes from, according to the many world interpretation. All right, so that's the many worlds interpretation in a nutshell. Hopefully that gives you some idea of how that works. And again, I think that just by making the figure, some of these ideas will become more clear to you. And of course, you can watch this video again. All right, now here's the alternative picture. In the alternative picture, let me blow this up temporarily. All right, the alternative picture, the physical world is the green line here. This other dimension, now in my other paper I call it the alpha dimension, but it turns out I found another person's work that does similar work, and he calls this the lambda dimension. So I'm going to call this the lambda dimension. And I can explain to you what the other person has done, which is kind of enhances what the other paper that I wrote. Okay, so what happens here is you have events in the physical world. There are only one set of events, only one physical world. but they're what you might call pre-events that occur in the lambda dimension. Now, these red lines show the domain of influence of each event. The event here in the physical world is influenced by every pre-event in this red cone. Okay? So, for instance, this blue event here does affect this pink event here. It also affects this purple event here because it's in the cone of the purple event. Okay? So each event in physical space has a cone of influence, and some events some pre-events may be in more than one cone. Like, for instance, this event here is in 3 cones. It has influence on this event, and on this event. So I think you can see here the relationship between this picture and the picture that we have of the quantum game show. You know, choosing the door, the entangled photon emission and choosing the door all have influence below, and there's a correlation there because they're both in the same in the cones of different events. You have the same pre-event in the cone of different events. All right. So the physical world is the green line. The pink or purple are the events in the physical world. So there are 2 alternative outcomes. The red V's are domains of influence for each event. The blue are pre-events in the lambda dimension. The lambda dimension is not observable. It's outside of space and time. All we can see is the green. There's no way to directly access what's out here because everything that we do is in space and time. Okay. Events in the physical world have overlapping domains of influence, and they're influenced by some of the same pre-events. All right. So that's the picture here. Now, if you compare this picture to the picture up there, I just ask you, which do you think is simpler? This one, you don't have, here you have very complicated topology where you have branching exponentially. Here there's no branching at all. There's just a space that continues without change and just different events that are located in the space, and you have influence that propagates and influences the different events that occur physically. All right. Okay. All right. So this is in 0 space dimension and 1 time dimension. So I tried to show this also for 1 space dimension and 1 time dimension. And this is I think in both cases, it's a little bit difficult to draw, but I think it's useful to see how this works because you kind of have to know how this picture have some idea of how this picture gets to 3 physical dimensions. Okay. All right, so you can see here that this is the many worlds picture. So this sheet at the bottom, that's sheet number 0. And here I tried to show that this event is in sheet 0. You see I drew lines to the axes. This event is in sheet 0. This event here is in sheet 1. And then you have these splitting events also. Now, what happens here is that because of the speed of light, when you get a splitting, this new sheet is only different on this cone here. All right, so the rest of it stays the same. So that's why show this complication. The only change is within this V. So it's kind of like, here's a sheet of paper. Here's the corner of a sheet of paper. Then here, when I have another splitting, here I have another corner of a sheet of paper. So you have all these corners of sheets of paper. It begins to look really very, very complicated. Okay. But this is the same idea. You get a splitting whenever you have an event with 2 alternatives. And then on each of these sheets, you can get further splittings, further splittings, further splittings. Eventually, you have a gazillion sheets. And here the topology again is very complicated. Now in the alternative picture, here is my space dimension. Here is my time dimension. Okay, maybe I should write that in. This one here is space. This one is time. All right, let's do it this way. This is space. And this is time. Okay. Now I have events in my space-time. Again, I only have 1 space-time. There's only 1 sheet down at the bottom. However, there's this lambda dimension up above. Okay. And the lambda dimension still has these pre-events up here. So these pre-events are in the limited dimension. All right. Now before, remember, I had a V of influence. Now I have a cone of influence. And like I said, it's a little bit hard to draw, but the cone, and this should remind you of the supersonic airplane. Okay. So this cone here goes up here, and you can see the opening here. So this is actually half a cone. It's interesting to think that maybe the limited dimension goes up and goes down, and then you'd have a full cone. That's kind of interesting to think about. Maybe that's something to think about. Okay, so that's what you have. Now this event here is influenced by pre-events that are inside of the cone of influence. So for instance, if I have a cone, if I have a pre-event that's here, inside that cone, that's going to influence this here. This pre-event is inside the cone here, so it's going to influence this one here. Now, if I had a point that's inside both, then it would influence both. So you can see that this is a direct generalization of the first picture. Maybe a little bit hard to draw, but I think the concept is pretty clear. The only difference here really is that instead of having a V, I have a cone. That's really the only difference here, which is really not a big change. Here you've got these strange pieces of paper that are skewed. It's just kind of strange. So I think this is a much simpler picture. So what I would say is please try to do your best with the zero-dimensional picture, and then we can discuss and maybe move on to the one-dimensional picture. All right. And of course you can watch this video as many times as you want. So hopefully that clarifies some of the issues. So thanks for watching.